Hi everyone. Today in this video we will be discussing convert the given NFA into its equivalent DFA. Another best example, and it's a little complicated as I have done some problems in my previous videos. If not watched those videos, please go watch those videos and come back to refer this problem. Okay. Right. This is a problem. So they have given problem here. First, as you all know, you need to find out what is e-closure of each of the state. So e-closure of the state 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So there is what is e-closure? E-closure is a set of state which are reachable from Q without taking input. That means you can able to reach from one state to other state without taking any input. So that is called as e-closure. Right? So you all know that how to find out the e-closure. The e-closure of first you have to find out the e-closure of 0. E-closure of 0. What is the e-closure of 0? E-closure of 0 is e-closure of 0. You can able to from 0 you can able to reach 1, 2, 4 and also 7. 0, 1, 2, 4, 7. Right? So that is a e-closure of 0. So I have given one name for it, that is a A. Why? Instead of using each time 0, 1, 2, 4, 4, 7, I can use one alias name for it, that is for simplification purpose, A. Right? So there is have given A, right? For that you have to find out the transition. Delta of A comma, what are the input is here? A and B. Right? So in this delta of A comma A, so delta of A comma A is nothing but where do you have the transition in this set? 2 to 3 and 7 to 8. That is reason you are getting delta of A comma A is equal to 3 comma 8. For that again you have to find out the e-closure of 3 comma 8. E-closure of 3 comma 8 is what? E-closure of 3 comma 8 is 3, 7, then 1, 2, 4. Then what is the e-closure of 8? E-closure of 8 is 8 only. That's the reason 3, 6, 7, 1, 2, 4 and also 8. You have to rearrange them. Okay. Then you can, which is not equal to A, then I can give one more name for it. Okay. So then delta of A comma A is over. Similarly for delta A comma B, where do you have the transition on this? Okay. 4. There is only one transition, then 4 to 5. So 4 to 5, that is only 5. E-closure of 5 is what? E-closure of 5 is you can able to reach 6, 7, then also you can be reach without taking an input. From 1 you can able to reach 2, then 4. Then if I get like this, you have to rearrange them. This is not similar to A and B, then you can give another name for it. Okay. Then once you understand this, then let us move to the from A you get new state B and C. Then you have to find out the transition for B. B comma A is nothing but this is B. B is 1, 2, 3, 4, 6, 7, 8. Where do you get the transition on A, small a? 3 on A, 2 on A. 2 on A is 3 and 7 on A, because since 3 and 2 on 7 is existing set B. Okay. Again you have to find out the e-closure of 3 comma 8, you already computed e-closure of 3 comma 8, that will be the 1 2 3 4 6 7 8, which is similar to B, then you can rename them. Then delta of B comma B, B comma B, then where do you get the transition on B? So one it is from delta of 4 comma 5, that is 5, then another it is 8 is exist in B, right? So 8 on B will go to 9, so that is a reason 5 comma 9. 5 comma 9, once you get the 5 comma 9, for that again find out the e-closure. E-closure of 5 comma 9 is, so e-closure of 5 is what? E-closure of 5 is 5 6 7 1 2 4, and e-closure of 9 is what? 10. Sorry, e-closure of 9 is 9 only, will not be go to any of the state, will not be go to any of the state, that itself. So that's a reason you have rearrange them 1 2 4 5 6 7, this will be e-closure of 5, then 9 is included since it is not going any of the state, that itself is. This is not similar to A, B, C, then you have to give a name, other name D. Okay, that is for only simplification purpose I have given the name, alias name for each of the set of state. B is over. Similarly for C. C on A we will get C on A 2 to 3, another one is 7 to 8, that is the e-closure 3 comma 8 C on C comma A. C comma A. For that you have to find out the e-closure of 3 comma 8. E-closure of 3 comma 8 is 1 2 3 4 6 7 8. This is similar to B. Then e-closure of C comma B. C comma B is 5, right? There is only one transition. There is a 4 is exist in the set C. Delta the 4 on B will go to 5. So 5 will get the e-closure. E-closure of 5 is already computed. It is 1 2 4 5 6 7, which is similar to C, which is similar to C. Okay, then once you understand this, so then C is over, then D. So D on A, so there is D on A, here it is, look at that, D on A will get the 3 comma 8, e-closure of 3 comma 8 is, you already computed 3 comma 8 is B, right? So 3 6 7, 3 6 7 1 2 4 8, rearrange them, you will get this 1 2 3 4 6 7 8, which is similar to B. That's the reason I have given B. Another one is D comma B. So other transition on input, delta of D comma B, it is, so there is, what is that here? D is nothing but 9, right? One is on 4, another one is 9. 9 on B will go to 10. Another is 4 on B will go to 5. So that's the reason you will get this 5 comma 10. For that you have to find out again e-closure. E-closure of 5 is 5 6 7 1 2 4. You can reach this state without taking any input. Then what is the e-closure of 10? That is its e-closure of 10 will not be go to any of the state, that itself, right? 10 is added. So this will be the new combination 1 2 4 5 6 7 10, which is not similar to any of the previous states A, B, C, D, right? You have to give one more name. You have to give one more name for that. Okay. So then let us move to the D is over. Then E on A. 3 comma 8 again. So e-closure of 3 comma 8 is, you already computed, which is similar to B. E-closure of B is 5 is also computed already. That is e-closure of 5 is 1 2 4. E-closure of 5 is 5 6 7 1 2 4. 1 2 4 5 6 7 is similar to C. I think I have completed there is no more new state exist in this. All have pointed the E closure as well as corresponding transition for each of the state, new state. The new states are A, B, A, B, A, B, B, D, C, and E, right? All it is computed, right? Now, so then it's a over, right? Then you have to stop the process, then construct the DFA. Construct the DFA. Construct the DFA. It is all A, B, C, D, E, right? Then corresponding transition table. So A on A will go to B, A on B, look at this, I'll explain this. A on A will go to this one, A on A will go to A, on A will go to B, A on B will go to C, right? So similarly for all this, why E is a final state? E is a final state since contains the E contains the right. Okay, since E contains the final state of given Epsilon-NFA, so that's the reason you have made it. This will be the final transition diagram and corresponding transition table. Hope you understand this concept. Do you have any questions? Please you have to comment in the comments box. Thank you.